So we have know how to find the equation of line from the vector, and we can write the equation of line in terms of symmetric equations and also the parametric equations. Now we are going to the next topic in the lines in space, which is angle between lines. How to find the angle between lines. Now we consider there are two straight lines, where the first line is represented as L1 and the second line is represented as L2. So our L1 here, it passed through a point of x1, y1 and z1, and it is parallel to vector u, where we write it as equals to ai plus bj plus ck. And we have our line 2, which is parallel to another vector, which is v, where v is equals to di plus ej plus ck. So we can, let's say we draw this line, these two lines in terms like this. So this will be our line 1 and our line 2. So now our focus is to how to find the angle between these two lines. So how to find this? This is by using the formula given, where to find the angle between lines L1 and L2, we need to use this formula, where cos theta is equals to u dot v. So this is the dot product, where we will get a scalar, and we divide by the magnitude of u times with the magnitude of v, which also give a scalar. And in order to find the theta, we will have to find the inverse cos of this scalar. Now let us try the example 1 to find the angle between two lines, which given L1 is in terms of this symmetric equation and L2 in terms of this symmetric equation. So to find the angle, we need to know the vector that is parallel to L1 and another vector that is parallel to L2. However, before we find the vector from the symmetric equations, what we need to make sure is that we have to make sure our x, y, and z for both equations must be multiplied with positive 1. So here for all x, y, and z, it is multiplied with constant plus 1. So we don't have to change it to plus 1 constant. Okay. Since we don't have to do anything, we can just straight away take the vector which is parallel to L1. So in order to find the vector of that is parallel to L1, we can write it as u. We just take the value that is in the lower part. So the vector of u is equals to 6, 3, and 2. And for L2, the vector we represent it as v is equals to 3, 4, and 5. So now to find the angle, we know that the formula given is cos theta equals to u dot v over the magnitude of u times with the magnitude of v. So first, we find the dot product of u dot v. So here will be equals to 6, 3, 2 dot with 3, 4, and 5. So we multiply 6 and 3 plus with 3 times 4 plus 2 times 5. So the answer will be equals to 40. Now the next step is to find the magnitude of u, where we have to find the square root of x squared, which is 6 squared plus 3 squared plus 2 squared, which is equals to square root of 49 equals to 7. Then find the magnitude of v, which is equals to 3 squared plus 4 squared plus 5 squared, and we have equals to square root of 50. So here we have equals to this, okay, square root of 50. So now just substitute into the equation the formula. So we have here is 40 over 7 times with square root of 50. So our theta will be equals to 36.09 degree.